Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create our own custom object detection model which detect number plate, and we are going to use here Raspberry Pi 4 camera module for detection. So in last session we create our own custom object detection model which detect number plate, and then we convert the model into TF light format. So in this session we are going to use same steps, only we are going to detect here a number plate with the help of our Raspberry Pi 4 camera module in real time. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we are going to create our own custom object detection model which detect a number plate, and then we are going to use a paddle OCR which we use in last session, where we detect a number plate and we read the number plate text with the help of paddle OCR on Raspberry Pi 4 bookworm 64-bit version. So we are going to follow same step which we done in last session, but here only we are going to use Raspberry Pi 4 camera module and we are going to detect number plate in real time. Also we are going to use a paddle OCR for reading the text from number plate. So before we start our practical, so if you don't know how to convert yolov10 n.pt model, which is the latest object detection method, so how to convert the model into TF light format, I have already created a video. So watch video, then you will get the idea how to convert the model and how to use the model, the TF light format model, with Raspberry Pi 4 bookworm 64-bit version. So I have already done with package installation, and I have already done with all this basic configuration. So watch the first video and then you will get the idea how to configure all these basic things, how to install packages and all these things. So I have done with basic configuration. So now for today's session I have created a new repository, rpycam number plate. I will mention the link. You need to simply copy paste the link inside the web browser. Then we are going to simply download our repository. So just click on code and click on download zip. It will download our zip format repository. As you can see, it's downloaded. Now let's just go here, file manager, and then just open download folder, right click to the repository and click on extract here. It will extract our repository as a folder, as simple as. And then simply we are going to move our repository, cut inside our home folder. That's it, as you can see. So as I mentioned friends, if you don't know how to configure Raspberry Pi 4 camera module, I have already created the video. I will mention the link. Watch video and connect the camera module with Raspberry Pi 4, which I have already done. Now let's just open our folder. This is what our repository folder. So first, because as I mentioned, we are going to create our own custom object detection model. So first we need our label img software. So for that we are going to install our label img software. So let's just open our terminal, and if I run here ls command, this is what our repository, as you can see, rpycam number plate main. Inside that repository we have label img.sh. As you can see, we have our bash script which basically we are going to run on our terminal, and it will install label img software on our bookworm 64-bit version. This is the latest version. So first just go inside our repository. So run the command cd space rpy and press tab button. It will auto complete our folder name. Hit enter. Now we are inside our folder, or we can say repository. As you can see, rpycam. And here, as I mentioned, here we have our label img.sh. So first we are going to mention full permission for our label img.sh, a bash script. So run the command like this way: sudo, then sudo space chmod 775, and then we are going to mention our bash script name, which is label img.sh, and then hit enter. So this is how we mention full permission: sudo chmod space 775 and mention the bash script name, which is label img.sh. Done. Now if I run ls command, as you can see the script is now green. Why? Because we mentioned a full permission. Done. Now just run the script. So bash space label img, just press tab button and then hit enter. It will install label img software on our bookworm 64-bit version. So friends, we done. We successfully install our label img. So if I run here cd and just come out from our folder and run clear. Now if I type here lab and if I press the tab button, as you can see, this is what our command label img. It means we successfully install label img. So labe and just press tab button, it will auto complete our command, which is label I is capital mg, and then if I hit enter, it will open our label img software. As you can see friends, we have our label img software. So we have done with label img installation. Now we need images. So inside repository I have create img.py, which basically run our Raspberry Pi 4 camera module, and with the help of camera module we are going to capture live number plate images. So I have here some number plate images inside my mobile. So I will just show the mobile number plate image front of my Raspberry Pi camera module, and then it will capture image. It will capture basically all the images. So let's just first run our img.py. So Thony file open, then go to the home and our repository and img.py, just click on OK. It will open img.py. As you can see here, I have mentioned Pi camera 2, which is basically for our Raspberry Pi 4 camera module. Then here we want to mention our folder. So just open repository and inside that just create a new folder, mention the name images, click on OK, and right click to the images folder, copy the path, copy as path, and from images just remove all the things, just remove it like this way, and then press Ctrl+V. It will paste our new folder path, the images folder path, which we just create inside our repository. Simple. Now we are ready, and now just save the code, and when I will start the code, it will start Raspberry Pi 4 camera module, and then I will show the number plate images in front of camera module. Simple. And it will capture basically 100 images. Remember one thing friends, you can change the frames. You can mention here 1000 frames, but this is just a demo version, so 100 images is more than enough. So now I will start the code, and then I will show the number plate image. Simple. So let me start here a code. So friends, as you can see, we capture images. So if I go inside images folder and right click to the image and image viewer, as you can see, this is what my mobile, and as I mentioned, inside that I have just saved some number plate images. So this is the image we have done with images. Now simply we are going to train our images. So let's just open our label img software, minimize all these things, open terminal and run label img, label, and just press tab button. It will auto complete our command, hit enter. It will open our label img software. As you can see, now go to the opendir pi, our repository, rpicam number plate main, images folder, click on choose, and then it will open our images like this way, as you can see. Then change save dir, again go to the our repository, our images folder, and then click on choose. Done. Now here we are going to select YOLO because we need YOLO format text file .txt. So just select YOLO and then create rectangle box, and then we are going to simply draw a rectangle on our number plate like this way. That's it, and mention the class name, which is the number plate. Click on OK, then click on save, go for next image, create rectangle box, draw a rectangle box on our number plate or simply any object which you want to train. So just draw the rectangle box, click on OK, and class we already mentioned number plate. Then just click on save, go for next image, create rectangle box, and then draw a rectangle box, click on OK, and click on save. So if you open our repository where we create our images folder, this is what our repository, and we have images folder. Here it is, as you can see, we have image text file, image text file, image text file, means we are successfully drawing a rectangle on our object. So this is how I will draw a rectangle on each number plate. So meanwhile I will pause a video. So friends, as you can see, I have done with drawing rectangle on each image with the help of label img software. 100 image completed. Now just close the label img software, and if I go images, here it is, as you can see, each image and their txt file. So we have 100 images, so we have of course 99 and their text file. Done. Now what we will do here, inside repository, again we are going to create a new folder and mention the folder name freedom tech. So right click, new folder, freedom tech, click on OK. So we create a new folder, freedom tech. Just open the folder, and again here we are going to create two new folder, images, just click on OK. So we create a images folder, and the another folder is basically labels. So images, and the next one labels. Done. So we create freedom tech folder. Inside that folder we create images and labels folder. So now we have two folder. So first we will go inside images folder. So we are now inside images folder. Here again we are going to create a two new folder, training and validation. So right click, training, done, and then right click, new folder, validation, done. Training and validation inside images folder. So go back again, same way, go inside labels folder, same folder, training and validation. So right click, new folder, training, right click, new folder, validation, done. So this is how first create freedom tech folder, inside that create images and labels folder, then go to the images folder, create training and validation folder, then go to the labels folder, create training and validation folder. Now inside our repository we have our images and all the text file. Just press Ctrl+A, just copy all the things, right click, copy it, go back, go to the freedom tech, images, training, just paste it, go back, validation, just paste it, done. Go back, then image, labels, training, paste, then validation, and then paste it. So this is how we need to copy paste all the data from our images to freedom tech, images, training, validation, freedom tech, labels, training, validation, done. Now we will create freedom tech folder as our zip file. So let me clear the screen first, and if I run ls command, this is what our repository, cd rpy cam number plate main, just hit enter. Now we are inside our repository, and this is what our folder, as you can see, freedom tech. So now here what we'll do, we will create a freedom tech folder as a zip file. So run the command like this way, sudo space zip space hyphen capital, sorry, not capital, small r, sudo space zip space hyphen small r, then the file name which we want to generate, so freedomtech.zip, this is the file which we want to generate, and mention the folder name. So folder name is same, freedom tech, and then let me make full screen, freedom tech, and then make slash and star. It will zip all the content or all the data from our freedom tech, means it will zip all the images and their text files. So sudo space zip space hyphen r, then this is the file name which we want to generate, and this is the folder, and from this folder we are going to zip all the things which we have inside our freedom tech folder. Done. That's why slash and star. Hit enter. As you can see, it's zipping all the data from our freedom tech folder. So it will create a zip file. Now if you open our repository or folder, as you can see, we have our freedomtech.zip file. Now we need to move this file on our Google Drive. So I will open the Google Drive and then I will upload this freedomtech.zip on my Google Drive. So let me open my Google Drive. So friends, I have opened Google Drive and here we are going to upload our freedomtech.zip. So just click on new, then click on file upload, and then go to the home, our repository, and inside that we have freedomtech.zip. Just select it, click on open, and now it will upload our freedomtech.zip on our Google Drive. So meanwhile, just open Google Colab and just sign in with your Gmail ID and just click on upload, click on browse, and then just go to the home, our repository, and here we are going to select our file, our Google Colab file. Inside repository I have mentioned the Colab file for training purpose. So select it, rpapcam custom, click on open, and now it will upload our Colab file on Google Colab. So friends, we successfully upload our Colab file. Now just go to the runtime, change runtime type, select Python 3, select T4 GPU, click on save, and then click on connect. So friends, we successfully connected. Now just run the cell one by one. First cell, click on play button, it will run our first cell. Then the next cell, which is pip install Ultralytics, it will install Ultralytics package on our Colab machine. So done friends, as you can see, we successfully install Ultralytics package. Now next cell, just import the packages. Then we are going to cross check if Ultralytics is installed or not. So run the next cell, it will download yolov10 n.pt model, and it will detect the object from RoboFlow image, which is doc.jpeg, from roboflow.com, doc.jpeg image. So we done. As you can see friends, the result is basically exactly runs, detect, and predict. So if I just click on this folder icon, and then we have here runs, detect, and predict. Inside that we have .jpeg image, which is our, as you can see, object detected image. So here we detect object, dog, and person. Done. It means we successfully install our Ultralytics. Now let's just mount our Google Drive because we want our freedomtech.zip. So run the next cell. It will open this kind of window. Permit this notebook access your Google Drive files. Just click on connect to Google Drive. Then select your Gmail ID which you use for uploading the freedomtech.zip. So I have used this Gmail ID, so I have selected the Gmail ID. Then click on continue. Then scroll down, again click on continue. That's it. As you can see, now it will mount our Google Drive. So friends, we successfully mount our Google Drive, and as you can see, inside that we have our freedomtech.zip. Now run the next cell, it will create a dataset folder, and inside that it will unzip our freedomtech.zip. Done. So just click on this folder icon. If I click again, here we have our dataset folder. Just make like this way. Then we have freedom tech folder, and inside that we have images and labels. Done. Now here freedom tech, just click on this three dot, click on new file and create the file data.yaml. So data.yaml, and then just hit enter. As you can see, we have our data.yaml. So just double click data.yaml, and inside that repository I have mentioned data.txt file. So as you can see, this is what our data.txt. Right click, open as text editor. This is what our file data.txt, and just copy the code, copy it and paste inside data.yml here. Press Ctrl+V. Done. And now here let's just change the class name, number plate, and the number of classes, of course we have only one class. So we have done. Now just press Ctrl+S and save the data.yaml, then close it. We are ready, and now we are going to start our training. Here it is. As you can see, data.yml file 100 epochs, and of course we are going to use here a nano model which is yolov10 n.pt. So image size 240. So let's just first create our base.pt, which is the basic model, and then we are going to convert our basic model into TF-Lite format. So let's just run our cell. So friends, as you can see, 1 out of 100, it means our training is started. So it will take some time. Meanwhile, I will pause video. So friends, we have completed our training process, and our model is basically saved inside runs, detect and train folder. So if you just click on the runs folder, then we have detect, then we have train folder, not predict. We have train folder, just select it, train folder, then wait folder, and inside that we have our base.pt model. This is the PT format, means yolov10 n.pt format model. So we want to convert this .pt model into TF-Lite format. So next code, here it is. As you can see, here we want to mention our model path. So just runs, detect, train, waits, base.pt. So here just select this three dot and then click on copy path, and here just remove the old path, and then just press Ctrl+V like this way. In single quote, we want to copy paste our model path. Done. Now format TF-Lite. Now it will convert our base.pt model into TF-Lite format. So run the cell. So friends, we have successfully converted our model into TF-Lite format, and our model is basically saved inside runs, detect, train, wait, base save model folder, and there is our base float32.tf-lite model. So if you just click on this folder icon, we have here runs folder, then we have detect folder, train folder, then we have here waits folder, then we have here base save model folder, and inside that we have our model base float32. So just select this three dot, click on download, and it will download our model. So friends, we successfully download our model. As you can see, this is what our model. So minimize the browser, minimize all these things, minimize terminal, and just open our file manager, go to the repository. Oh sorry, not repository. First our model is basically download inside downloads folder. So go to the downloads, and this is what our model. Right click, cut, go to the home, our repository, and then just paste our model over here. Now we are ready, and first here we need to create our custom label file. So right click, new file, coco1.txt, click on OK, right click to the coco1.txt text editor, and this is what our coco1.txt, and here we are going to mention our class name, which is number plate file, and just click on save. Done. And now we are going to open our main code, which is test.py. So right click to the test.py and Thony. It will open our test.py with the help of Thony Python IDE. So friends, as you can see, this is what our test.py, and here we import our modules. So here only we add PyCamera2, import PyCamera2. This is the new module which we add, and all other modules are the same which we use in last session for detecting number plate, also reading the text from number plate. We have here pedal OCR, we have here ultralytics, we have here our CV2, then CV zone model, and then pedal OCR. Done. So we import all the models which we use in last session, only we add here PyCamera2. And let me check here if I have installed a CV zone. So if I just go here tools, and because this is completely fresh installation, so CV zone, if I hit enter, click on CV zone, and as you can see I forget to install CV zone, so I have installing CV zone over here. So friends, as you can see I have installed CV zone. So as I mentioned, for this video you have to first watch the basic video, how to install all the packages, how to convert the model into TF-Lite format. So watch the video and then you will get idea. So same code, same function, perform OCR, same way, all the things are same, only we mention here PyCam to capture array for calling the frame, for capturing the frame from our camera module. And then we have our detection, and here I have mentioned our model name also, best float 32.tflite model. And then we have detection, then of course we are going to crop our detector rectangle, and then text perform OCR, we are going to pass our crop image inside our perform OCR, our function. This is the function where we mention our pedal OCR, and then we have detection, and then we are going to read the text, and then we are going to put the text on rectangle top left corner. This is the code which we use in last session. Same code, only we add, as I mentioned, only we add PyCamera2 for capturing the frame with the help of our Raspberry Pi 4 camera module. Done. Now let's just run our code. So friends, as you can see, it's detecting the number plate. I have here a number plate image inside my mobile, so it's detecting the number plate, and there is a text on the rectangle top left corner. As you can see, RJ14CV0002, simple RJ14CV0002. So it's detecting the number plate, also it's reading the text. So I have here another image also. As you can see, it's detecting the number plate 22BH6517A. 22BH6517A. As you can see, it's detecting our number plate, and with the help of pedal OCR, we are reading the text. So as I mentioned friends, I have here only 100 images which I use for training purpose, but in real scenario you need a more image, then it will detect a perfect number plate, but still the result is really good. So we create our own model, then we convert the model into TF-Lite format, and then with the help of pedal OCR we are reading the text from our number plate using Raspberry Pi 4 camera module. So I have mentioned the full code. As I mentioned before this video, you have to watch a basic video, then you will get more idea. So we'll meet our next video. Till then, thank you, take care, and bye bye.